Hey guys, so today this video is about section 10.4, solving trigonometric equations. And before we do that, we're going to start with solving just a regular equation to sort of think a little bit more deeply about what it is we're doing when we're solving an equation. So let's solve for x. Okay, the first thing I would do would be to subtract 3. And then I would divide both sides by 4. And so my answer would be -1/2. Solving for x means isolating x, getting x alone on one side of the equation and a numerical value on the other side of the equation. When we solve trig equations, there's an additional step here. Let's look at our first example. So our first example will be to solve, now don't worry about what that means for just a second. Let's solve this equation. Instead of x here, we've got cosine of x plus 3 equals 1. Notice I made it so that it's just like this one, only here we were solving for x, 4 something plus 1 plus 3 equals 1. Here we're solving for something else, cosine x, 4 something plus 3 equals 1. So they're the same equation almost. Our first step for trig equations will always be we don't want to try to think of solving for x right away. We want to think of it like our first step is to solve for that trig function, which in this case is cosine x. So just like before, I'll subtract 3 from both sides. I'll divide both sides by 4. And just like before, I get -1/2. Whoops. But here, I'm not done, because I haven't solved for x yet. My first step was to solve for the trig function of x, cosine of x. Finding out what the answer is from here is the sort of new part. What values of x, what angles exist such that cosine of that angle equals -1/2? Now, one way to think of this is using inverse trig functions. Inverse cosine of -1/2 equals what angle? But another way to think of this is to think of our unit circle. Here's where the unit circle starts being really helpful. There it is, pretty good. Now, one thing I know about whatever angle this is, cosine of some angle that equals -1/2, is I know that cosine of that angle is negative. So, all students take calculus. Which quadrants have angles that cosine of those angles are negative? Not this one, they're all positive there. And not this one, cosine and its reciprocal are positive there. So I know that there's going to be an answer for this angle in quadrant 2 and in quadrant 3. Okay? Remember that in the unit circle, I'll draw it over here even though that's not where the angle is going to be. In the unit circle, the radius is always 1, right? And so we've memorized that cosine of an angle is x over r. But in the unit circle, r is 1, and so we can just say in the unit circle that cosine of an angle is just the x value. And sine of an angle, which is normally y over r, in the unit circle, r is 1, y over 1 is just y. So in the unit circle, sine is just the y value. I want to know where cosine is -1/2. Now, don't be confused by the fact that the variable is in x. It could be any variable at all. Cosine of what angle equals -1/2? Well, cosine is x on the unit circle. X equals, if this is the point -1, 0, here's where x equals -1/2, right? This corresponds with x equals -1/2. What two angles have an x value here? This angle, -1/2 comma something, right? Do we agree that the x value is -1/2 right there? And this angle, this is -1/2 comma something. Now the question is for us to find out what is this angle and what is this angle. Those will be our answers. Okay, well, to do that, I've got to think of my special right triangles. Now you may already know at this point that 1/2 comes from a 30, 60, 90, but let's say that I forgot that. Here's my right triangle. I know because it's the unit circle that the hypotenuse is 1. I know the x value here is -1/2, so the length of this side is 1/2. What kind of triangle has these proportions? A 30, 60, 90. This side would be root 3 over 2. So if I wanted to fill this in, this point is negative 1/2 comma root 3 over 2. Let me zoom in a little bit here. So what angle is this? This is a 60-degree angle, which means this is 90 degrees plus 30 degrees. This is 120 degrees. Now, when we're solving trig functions, all of our answers will be in radians. It's okay if you convert 120 to radians, but at this point it's also going to be helpful if you can start thinking in radians. This is pi, right? From here to here is pi. So this is 1/3 of the way, pi over 3. This is 2/3 of the way, 2 pi over 3, which is also what we get if we convert 120 to radians. So one of my answers for x is that x equals 2 pi over 3. That's this angle. And cosine of 2 pi over 3 does indeed equal negative 1/2. Okay, so what's this angle down here? What's this one? This is 1 pi over 3, 2 pi over 3. 3 pi over 3 is pi, and I know that that's pi on the unit circle. So this would be 4 pi over 3. That also has an x value of negative 1/2. And cosine, remember, is the x value of that angle. So my answers for 4 cosine x plus 3 equals 1 are that x can equal 2 pi over 3 and 4 pi over 3. And let's just confirm that that's true. So I'll turn on my calculator, make sure I'm in radians, which I am. Okay, let's plug it in. 4 cosine of, let's do 2 pi over 3 plus 3. Okay, I'm hoping to get 1 here so that my equation, 4 cosine x plus 3 will equal 1. I found a true solution to that equation with 2 pi over 3. Let's see. Hooray! Okay, the same happens if I plug in 4 pi over 3. We're going to do some more examples, but before we do, I want us to think about this part that we chose earlier to ignore for a moment. Solve on the interval x is between 0 and 2 pi. That means I only want to give answers from 0 to 2 pi. 2 pi over 3 is between 0 and 2 pi, and so is 4 pi over 3. But aren't there more solutions here? Couldn't I say negative 2 pi over 3? In degrees, that would be negative 120 degrees. Wouldn't that also get me to this angle? And that would be another solution to this equation. For that matter, I could say negative 4 pi over 3 to get here. In fact, if I just look at this angle, I can add or I can subtract 2 pi as many times as I want to get to a coterminal angle, which actually means there's an infinite number of solutions to this equation. But because the instructions only asked me to give the answers from 0 to 2 pi, there are only 2 answers here that I can see on the unit circle, 1, 2, and one of them corresponds with 2 pi over 3, and one of them corresponds with 4 pi over 3, and so that's it. Okay? Sometimes, though, we'll be asked to find all of those infinite solutions. It'll say, find the general solution of 4 cosine x plus 3 equals 1. We'll go through the same process that we did up here. We'll find out that cosine x equals negative 1/2. Then we'll find out that that corresponds to these 2 places on the unit circle. I'm going to erase this so that you don't get confused. These 2 angles on the unit circle have a cosine value of negative 1/2. But rather than just giving 2 pi over 3 and 4 pi over 3, I want to include every possible solution, including negative 2 pi over 3, negative 4 pi over 3, also 2 pi over 3 plus 2 pi, also 2 pi over 3 plus 2 pi plus 2 pi again. Any multiple of 2 pi will bring me back to the same place I started because 2 pi is once around the circle. So when I give my general solution, I would have to go through all these steps that I just did, but I wouldn't stop here at x equals 2 pi over 3 and 4 pi over 3. Instead, I would say, you know what? X can be 2 pi over 3 or 4 pi over 3. But from 2 pi over 3, I can add 2 pi to get to another angle that's also true, a coterminal angle. Or I could add 4 pi, or I could add 6 pi, or I could subtract 6 pi or subtract 8 pi. Any integer multiple of 2 pi will work. And so we say that our general solution is 2 pi over 3 plus 2 pi n, where n is an integer. Now, I'm not going to make you write that. It's understood from the context that when you write plus 2 pi n to give your general solution, it's understood that n is an integer. Any angle that's coterminal with 4 pi over 3 is also a solution, and so my other general solution is 4 pi over 3 plus 2 pi n. And these would be my answers. 2 pi over 3 plus 2 pi n, and 4 pi over 3 plus 2 pi n. And you know what? Let's check that on our calculator too. I want to see if 4 cosine of some angle plus 3 equals 1. And I'm going to plug in, let's see, I'll check one of these general solutions, 4 pi over 3 plus 2 pi n. Remember, I can pick any integer I want for n, and it should still be a solution. What's a really fun integer? How about 101? Okay, so I'm going to plug in 4 pi over 3 plus 2 pi times 101. Any integer I pick would work, plus 3. So I'm plugging in a solution for 4 cosine of x plus 3 equals, and I'm hoping it will equal 1, let's see. And it still does, okay? Any integer I pick will give me a solution as well. So we did the same problem twice, basically, but once we were asked to find only the solutions between 0 and 2 pi, and there were 2. And the other time we were asked to find the general solution, and they're an infinite number. Any value I plug in, any integer value I plug in for n to either of these two equations will give me a solution. All right, we're going to do some more practice in the next video.